Hello everyone. In today's episode, I will continue with a more complex agentic system than the previous one. So in the previous episode, I made a few agents on Azure Foundry, and then I also made a Python application that orchestrates these agents. But this application was just doing a simple sequential orchestration, so it was not really agentic. And in this episode, we're going to go one step further and explain a little bit more what is going on. So, yeah, this is how this episode will work. We have a client. Client is has a front end. The client calls a backend, and backend now uses Langgraph. And Langgraph is a popular framework for agent orchestration. Langgraph is actually representing, say, agents as nodes, and then it orchestrates these nodes, and the nodes are put in a graph called state graph. And actually, in this case, because our agents are actually coming from Azure AI Foundry, these are just Azure AI Foundry agents. They will just agent nodes will be Azure AI agents, but then the orchestrator node, but we don't want it to be our Azure AI agent node in a sense, because we want more control over what is going on. Azure AI agent can also orchestrate the other Azure AI agents in different ways, so we don't want that. We want more control about the orchestration. So we have orchestrator node. Then orchestrator node actually uses Azure OpenAI to orchestrate the other agents. Now, let's go a little bit more in depth how it is going. So the orchestrator node is orchestrating other agents. How it does? Well, it knows that there is a, let's say, an order of the agents that need to be followed. So there should be first intake agent and verification agent and eligibility agent. But it now doesn't do it programmatically. It does it by understanding that it needs to go through this process. And then, for example, when a user comes in, the user can provide some information to the orchestrator node, and then orchestrator node calls these agents, but then it calls them in a sense by first examining what is in the message from the user. And then, for example, in the first case on a previous episode, each time another agent was called, the user had to put some more data and it was asked from him. But sometimes the user can already give enough data for the intake agent, and then the verification agent can just check that data. And previously, that was not the case. These agents would just have to be called sequentially with user interaction between them. But now the orchestrator node orchestrates the agents. So if after the intake there is enough data to go through the whole process, the orchestrator node will just orchestrate the process and will just call the other agents, check things, and finish the whole process. Now we are still having these agents as well, or let's say they need to produce more formal output, such that orchestrate node can orchestrate them. But now actually this, or let's say previously they had to produce this output, now they can produce less formal output in the orchestrator node because it is using GenAI to orchestrate the whole system. They don't need to be so formal. But because I did not want to make new agents, right now these agents just respond as pass and fail, and then if it's pass, then the orchestrator node knows that this agent passed, and then it can check the other agents if it has enough information. And then if the fail means that the user needs to provide more information. Now let's go a little bit further now. How does it work? Actually, the user sends a chat message to the fast API. The fast API updates some session history, then it invokes the Langgraph. The Langgraph calls the orchestrator, and then in the loop, orchestrator orchestrates other agents as much as it could, so as far as it could, based on the data that it has. Now, let's discuss a little bit more about the memory, because memory is also one of the things that is quite interesting and important when you're dealing with agents. And in this case, we actually have two, you can say, levels of memory. One level of memory is a session, and the session is keeping the data between, let's say, the user calls. So when a user calls something, then the session is updated with new information, and then after the orchestrator is performed his job, then the session is again updated with information from orchestrator, and the session is more like a permanent memory in a sense. But then now the Langgraph actually has its own intermediate memory, and this memory we'll talk more very soon. So this is the agent state. Actually, the agent state is the state that is used in Langgraph. So Langgraph, when it goes from node to node, when it invokes nodes, then it in this evocation it uses agent state. And agent state is a type dictionary, so it has a lot of information that is needed for these agents to properly do the job and communicate. So this is like a temporary memory. So every time that Langgraph is working, these agent states are being made, being processed. And then when the Langgraph is finished, then the output is then put into the small or permanent memory, let's say, that is in session. So it's a session dictionary. It has some status, steps. So we go through steps. The steps are actually agents, and then it has some customer data. So this has more information about customer, information about chat, information about results, information about thread IDs that let us follow the, let's say, the agents in the individual agents from Azure AI Foundry, etc. So you can see all of the data in here. And then, well, there is nothing too much to say about it. I will just go very shortly to how it actually works. So in the main, there is a chat endpoint. The chat endpoint is based on a session ID because we want to make sure that a user is working with a session when the chat endpoint receives some data from the user, then the session is retrieved. We see what is the current stuff, we see what is the user message, then we extract some data from the message. To be fair, like this part should probably be done in agents, but nevertheless, extract the date of birth, address, consent, documents, then we prepare things for the Langgraph, set the initial state for the Langgraph, and then we actually invoke the Langgraph. And let's go a little bit into that. So the Langgraph is here. So you see this is the agent state that keeps information between the Langgraph calls of their nodes. And this is the orchestrator node. It defines how the orchestrator node does. Then each agent node, well, we know that agent actually is a generic entity. And we can just set the ID of the agent, the name of the agent, and then each agent just does what it needs to do. So this is a generic thing for creating agent nodes on the spot. And then you have some workflow that you make as a state graph. You add some nodes, you add first the orchestrator node, you add other nodes, and then you add the roots. So at the enter point, you add some conditional edges from the orchestrator to where it needs to go, depending on the state and what is the output of previous state. And then you compile the graph, and then this is how your orchestrative AI will support you. And then very short, I will not repeat this. So this was the agent caller. This was the same. So the agent caller, the caller of the agents is, we already defined it, and I think in here, yeah, you can see in here that this is now in the create agent node. So each agent node actually calls the Azure AI agent with the name of the agent, with the key, and with some data. So this is a more complex example, and next time I will go into even more complex examples. Thank you everybody.